Running a coffee shop takes a lot of moving parts, and every cup creates a trail of information. But here's the catch. Not all of that information behaves by the same mathematical rules. Sometimes the numbers we collect are really just words in disguise. Other times, words give us strict mathematical limits. Depending on what kind of information you are looking at, the rules of what you can actually do with it change entirely. We can think of this as a staircase. As we step up from the bottom level to the top, our information gains more mathematical power and precision. Figuring out exactly which step of the staircase your information lives on is the only way to know which mathematical tools you can safely use for your business. Let's start at the very first step, nominal data. Imagine a customer orders a drink. They might ask for an oat milk latte, or they might ask for a black tea. These are pure descriptive labels. You cannot add a latte to a tea, and you cannot subtract them. You can only drop them into separate bins and say whether two orders are the same or different. Now, let's step up to the second level, ordinal data. This time, our customer is choosing a cup size, small, medium, or large. Along with categorizing things, we can now rank them. We know for a fact that a large cup holds more volume than a small one, so we can line up these sizes in a clear, logical order. But there is a strict limitation here. While we know the order, the exact mathematical distance between a medium and a large is unknown. The jump from small to medium might be 4 ounces, while the jump from medium to large might be 8. We know the rank, but not the actual distance. Because these first two steps lack that precise, consistent distance between values, we can count categories and rank preferences, but we are limited in the type of arithmetic we can perform. To do heavier math, we have to move up to metric numbers. Up here, the distance between any 2 points has concrete, measurable meaning. Take our third step, interval data. Imagine a barista steams a pitcher of milk to exactly 60 degrees Celsius. In this scale, the space between the numbers is uniform. The 20-degree gap between 40 and 60 is identical to the 20-degree gap between 60 and 80. This allows us to accurately add and subtract temperatures to find the difference. However, even with consistent distances, we still don't have a true starting point. If the thermometer drops to 0 degrees, the measurement doesn't just stop there, it continues straight down into negative numbers. That is because 0 degrees Celsius is just an agreed-upon waypoint, not the complete absence of heat. Because this 0 point is arbitrary, it restricts our math. We cannot accurately claim that 60 degrees is twice as hot as 30 degrees, because the scale does not actually start at a true bottom. Interval data gives us the power of exact distance, but without a true zero, our mathematical toolkit is still slightly restricted. Now we reach the top of the staircase. Look at a customer paying their final bill, exactly $4. This is ratio data. When the total on a receipt hits $0, it signifies the absolute absence of money. There is nothing left. Having a true zero changes what we can calculate. Because the baseline is real, we can finally determine proportions. We can say with total mathematical certainty that $4 is exactly twice as much as $2. There is one final variation at this top level, the absolute scale. Imagine a customer picking up exactly 3 individual sugar packets from the counter. Absolute scales deal in natural, individual units. You count them in whole numbers. Because you can't have half a sugar packet, trying to calculate a value like 2.3 packets makes no logical sense. Ratio and absolute scales sit at the very top because they give us exact distances and a true zero, providing the information needed for full statistics and arithmetic. If we zoom out, we can see all of the information generated by the cafe simultaneously. A single customer interaction, ordering a large latte for $4, heated to 70 degrees, spans all levels of our staircase at once. The danger is trying to do math that doesn't fit the category. If you assign the number 1 to a latte and 2 to a tea, a spreadsheet might tell you the average order is 1.5, but you can't serve a half latte, half tea hybrid. The math is technically right, but the result is meaningless. But when you apply those calculations to the metric numbers at the top of the staircase, you get clear results. You can calculate your exact average daily income or precisely track how fast you are burning through your inventory of cups. The same logic that organizes our cafe also organizes global health statistics, financial market analysis, and high-level scientific research. Understanding exactly where your information sits on the measurement staircase is the only way to accurately read the story your numbers are trying to tell.